Thank you. I'm excited to be here. I want to thank Dave and everybody for putting this conference on. This is always one of my favorite events to go to each year here in Utah. But I'm here to talk to you guys today about JavaScript, and I'm not really here to talk to you maybe about the exciting, the fun, the maybe even the sexy parts of JavaScript, like the new framework that everyone's excited about. I'm here to talk to you about the stuff it seems that nobody wants to talk about. Maybe even the dirty parts of the language. And that's why I call it the bowels of JavaScript. And I hope I don't offend anybody with that. But the bowels of JavaScript, specifically the way errors work in JavaScript. So I want to start off and ask the question to everyone, who here feels really confident in their understanding of how JavaScript works with errors? Woo. Yes, Tim, we've got one. We got a CTO back here, or director, chief director. Okay, well, I'm going to ask a lot of questions from the audience today too, because I want you to really look at a lot of my examples and see if you can figure out what's going on. And I'm not trying to be tricky per se. I want to see if we could all level up a little bit in how we understand JavaScript. But to start off again, my name is Bret Little. I'm a software developer at Canopy Tax. I love JavaScript. I tweet about JavaScript. I do not take pictures about JavaScript, but yeah, that's me. So, JavaScript errors burn. And so when I say they burn, what do I mean by they burn? Well, whether you know it or not, chances are your users are getting burned by JavaScript errors right now in your application. About a year and a half ago at Canopy, and I'm going to reveal some of my dirty little secrets to you here, and so I hope we're all friends. We're not going to judge each other too much. But this is not actual data from a year and a half ago at Canopy, but it was something similar to this. We've been tracking errors, but then all of a sudden we decided, I wonder how many of our errors that we've had over the past while, like given our daily unique users inside our application, what percentage of those saw errors? And when we started looking at that specific statistic on a day-to-day basis, I realized, oh my goodness, this is really bad. Like really bad. Like you're telling me that upwards of 10% of our users are seeing some kind of an error every day inside our app? That's really bad. And then what in the world happened on May 6th? It got up to like 30%. What is going on? So this is really, I feel like, why this is the dirty part of JavaScript. We have these problems, but nobody wants to talk about it, and really they're burning our users. So if there's nothing you take away from this talk, actually maybe I'll say that again a little bit later, but one thing I really want you to take away from this talk is I want you to go back to your application and try to figure out this statistic in your app. Like, what is the percentage of daily users, unique users inside your application that are seeing an error? And where are you at? Because if you don't know where you're at, how are you going to get better? And how are you going to really improve the experience of your users? Because like I said, JavaScript errors burn. So, well, how do you even start? How do you even get the statistic? So I'm just going to mention these briefly. I don't want to dwell upon these a huge amount directly, but there are a lot of JavaScript error tracking services out there. There's a wide range of them. Some of them you can self-host. Some of them are open source and free. Other ones cost a lot of money. I don't really care about that. The main thing that I want to really sell to you is that you need something inside your application to track your errors. Now the moment of truth. This is your doctor. I'm coming to you. Would you raise your hand if you use an error tracking service of some sort? Oh man. Okay, so the rest of you, I assume, are not. So I'm not going to make you raise your hand. So now this is probably the real key of this talk. I want you, when you leave this, when you go back to your work, adding one of these services can be as simple as adding 1 or 2 lines of code to your application. It is super easy to do, incredibly simple, and then you can actually get data about what's happening in your app. And that is key. That is super key. Okay, so again, I'm going to be asking you guys lots of questions as we go through this. But before we really talk about how JavaScript error handling works, I think it's worth recognizing how these tracking services work at a high level. So there is this magical event handler in the browser called window.onError. And a lot of these services do some magical stuff to track errors, but a lot of it comes back to this callback right here. Whenever there's an error inside your application, wherever it's at, when it happens, it's going to show up inside this callback. And it takes a couple parameters. It has a message parameter, and that describes the error that took place. It has the file that the error originated from, the line number in that file, and the column number. You may ask, why do I care about the column number? Well, some people minify their code and they have 4 lines but 20,000 columns. So that actually helps you find out where in the file it came from. But the most important thing really in here is actually this last parameter, the actual error object itself that was thrown. And why is this important? Because this is what actually gives us a stack trace. And if you don't get an error object in here, that sucks, because then you can't get a stack trace. Okay, so when we at Canopy started to dig into what kind of errors we had, well, we had a lot of these. And cannot read property such and such of undefined. I'm willing to bet if you've written JavaScript for any decent amount of time, you've seen this before. Okay, well that one, I'm aware of that one. We also saw these. What in the world is that? Failed to fetch. Like, I had no idea what that was. Like, okay, I don't know what that is, but we got a lot of them. That sucks, okay. We also had these, even worse. Who's seen that before? Oh my goodness, what is that? I've got no idea. That shows up on, so specifically I'm going to say Sentry a lot because we use Sentry, but I've used Track.js, I've also used Bugsnag to track errors. But in Sentry, we're seeing this object error. And it's just a string, there's no stack trace, there's nothing about it that gives me any information about where it came from. I'm just looking at this object error. Like, what is this? I've got no idea. And that's probably the worst situation to be in when you know that there are errors happening and you have no idea how to fix them. So let's look at the first one here. The first one, if you're not familiar with that, this is a simple example that will cause that. We have this function called makeError that defines an object, and inside that we're referencing object.foo.bar. So this is going to trigger an error that's going to say you cannot access property bar of undefined because foo does not exist on OBJ. That's simple enough, right? These are common, I found, in our code where we're hitting the server, we're accessing some sort of data on a JSON object, but the server isn't always returning the data that we thought it would, and so now we're getting some sort of error, which kind of sucks. But the most important thing to realize in this example is by triggering that error with that console log statement, that error is going to show up in window.onError. And because it shows up in window.onError, we can actually debug that. We'll have a stack trace to it. We'll be able to find it. We'll get a good message. That's debuggable. That's good. And usually with these types of errors, this is not something that's expected. It's like an error happened. But there are other types of errors where you can dynamically create an error. And when you dynamically create an error, you are expecting that that error is actually going to occur. So for example, we're triggering our tricobezoar error. And when we trigger that, we expect that to come up. It's coming up. We know it's going to happen, but when we trigger it and when we throw the tricobezoar, that shows up inside window.onError too, as we'd expect, right? Now I'm going to ask you guys a question. What happens when we throw our tricobezoar as just a string? It's not a new error object. What in the world does that do? Are there any problems with that? Or is that, I don't know. Okay, well, let's think about this a little bit. Let's think about what is an error object. When I create the tricobezoar error object, it creates this new, it's a native sort of thing. You can say new error when you want, but you get an object out, and that has a property, a message property on it called tricobezoar, whatever you passed in as in the constructor. It also has this magical stack property. That stack property is going to be populated when you create the error, not when you throw the error, when you create the error. So given that information, and so this is an example of what this stack trace could look like. It is browser specific. It isn't necessarily this, but it essentially says, this is the error, this is the function, the file with line and column number, the whole stack trace down to where the error originated from. So given that information, what happens when you throw a non-error object? Well, your life really sucks. So when you do that, essentially what's going to happen is nothing really that magical. When you throw a string, or when you throw a number, or you throw a Boolean, or a JSON object, or an array, or whatever it may be, that particular thing you throw is going to show up inside window.onError. But the error object that you thought you would get is not an error object. You know what that is? Instead, that's a string. So you have no stack trace. So that gets sent up to Sentry, no stack trace. You can't debug that. That's hard to, I've got no idea where to go find this thing. But also, it's even worse than that. If you throw an array, or you throw a JSON object, it's going to toString that thing that you threw, and that's going to show up as your message. And so all of a sudden, you're getting these object crap all over the place inside your application because you're throwing things that are not real error objects, which is not good. So when you usually trigger an error inside your application, in synchronous code, you can catch that error. When you catch the error, it is not going to show up inside window.onError. With the rest of my examples here, just imagine that there's a this window.onError callback going on at the top. And that's like to represent Sentry or Track.js or one of these services that's going to actually catch this thing, log it, and give us information about it. So what about asynchronous errors? What's going to happen here? So we have a set timeout that's executing a callback. That callback is just throwing a vermicularis error. So when that is triggered, are we going to catch that in our catch statement? Who thinks yes? Nobody. Good. Awesome. Because it's not. Because it's being executed on a new round of the event loop, the entire context of that synchronous code is gone. And so you're not going to be able to try catch this code. And this is kind of maybe one of those things that's a little bit rough for people to get their mind around when they first start coding in JavaScript, because this works, but this doesn't. And that's because it's asynchronous, and this make error is going to happen at some point in the future. But the important thing to realize here is at least our error that we're throwing is going to show up inside window.onError. Okay, how about promises? So we're calling this function makePromise, which is returning a new promise. Inside that promise callback, we are not resolving the promise. We're just throwing a vermicularis error. Okay, well, what is this going to do? I'm going to ask the question, is this going to show up in window.onError? Maybe. Who thinks it will? Some browsers it will. You think some browsers it will? Some browsers might warn you in the console. But no browsers that I'm aware of are actually going to show up in window.onError. So that's the problem here. When you execute a promise and you have any kind of error in that promise, any kind of error whatsoever, part of the specification of promises is that error is going to get swallowed. You will never know about it. It will, at least as far as I know of any browser, including the latest Chrome, you are never going to know about that. It is not going to show up inside window.onError. It might give you a warning, and that's only in the last like 6 months that the console's given you a warning about that, but it's going to be lost forever. And so instead, you have to add a .catch statement. Adding a .catch statement is going to allow this error to be caught, and you're going to actually know about it. In this example, I'm throwing an error, but I could be calling a function that's not defined. I could be doing all sorts of really nasty things that you're never going to know about. And that's an error burn. So my next question, really the previous example, we're not actually getting this to window.onError. This isn't actually getting out to our service, our tracking service. If we want to get this to our tracking service, how do we get it there? What about if we do this? What about inside our catch statement, can we throw that error? Is that going to show up inside window.onError? Who thinks yes? You guys are like all now like unsure about my questions, like nobody wants to go out on a limb. Okay, well, no, it will not. This will not show up in window.onError. Why? Because promises chain, and catch statements themselves produce a new promise. So if you really wanted to get that error out, you'd have to have a .catch below your .catch. So .catch, which kind of sucks. So it's like, okay, well, I want to get this error out of this promise chain. How do I do that? How do I make sure that this is even like I can know about it when it comes up? It's one thing if it's like I'm aware of the vermicularis error, but how about an error that I don't even expect is going to happen? Like some sort of logical error. Well, I'm never going to know about it. So I have a friend, Joel Denning, who once stated that all problems are surmountable with a well-placed set timeout. So yes, this will show up in windowed on error. But is that not horribly ugly and disgusting? That sucks. Well, your stack trace is not actually worthless, because where the error is created, oh wait, yes it is. Sorry. I totally gave away my punchline here. There's something wrong with this. What's wrong with this? Tim caught it. Oh my goodness. Our trichobezoar's back. We're throwing a non-error object. I'm throwing a string. We're not going to have a stack trace. Oh man. Okay, so if we threw new error, then we would have been good. We would actually have a decent stack trace. Okay. Does that make sense? Well, let's look at a more realistic example maybe that you might see inside your application. Let's look at a fetch an example. So fetch is a browser API that is new. It's essentially meant to replace AJAX. It's where you can make a request to the server, and instead of using callbacks, you can use promises. Okay, that sounds like that's pretty easy to do, right? So in this example, I have run app at the bottom. We're going to call fetch data. We're going to pass it a bad ID. Inside fetch data, we're going to call the native browser fetch API. We're going to hit a URL with this ID, and when that's going to resolve inside this .then function with this callback, and inside there, this response object, which is again native to the browser, there's this OK property on it. If the server responds with something that is a 400 error or a 500 error, response.OK will be false. But if it's a 200 level error, it's going to be true. Then we can return response.json and resolve and dispatch our data, but I don't really care about that. What I care about is what happens when response.OK is false. What do we do inside here? So we have a bad server response. How are we going to create our error? How are we going to do this? Well, we could do something simple. We could just say throw new error retrieving data with this ID, and then maybe we'd see our IDs undefined, and we're like, okay, that sucks. And then we can do this crappy thing with our set timeout at the bottom with our catch statement, and then we throw the error out. Yeah, that kind of works, but that kind of sucks, doesn't that? The set timeout sucks, but you know what especially is not good about this is when I come to debug this, I'm throwing an error, that error is getting logged, but the stack trace that I'm going to look at is only going to go to the callback that this is executed in. So in other words, I'm only going to know that fetch data was called. I'm never going to know who called fetch data. So I might have 50 different spots on my application that could call fetch data. When I'm trying to debug this, I have no idea which one actually called fetch data with a bad ID. I have no idea which one it was. The stack trace will not include run app in it because that's asynchronous. It was asynchronously executed, this entire callback inside fetch. So how could I make this better? How could I make this more debuggable so I can actually understand it later on? Well, it'd be great if I could have a long stack trace. Create the error object early. Did you know you can do that? So you can create an error object whenever you want. And when you create the error object, the moment that you create it, that's when it's going to define the stack trace. So because I'm creating it first in the function, immediately I'm going to have the whole stack trace of who called fetch data, where inside the application they called it, and have a much more useful stack trace than, oh, of course I know I'm inside fetch because the fetch failed. Like, now I have something useful. Also, we can improve this whole like set timeout stuff. Most of these tracking libraries allow you to directly capture an exception. So rather than doing the set timeout obnoxious stuff, I can just say raven.capture exception. Raven is what Sentry uses. Track.js will have something similar. So this is much more useful. And one part of it I want to point out too is you can mutate. I don't know if I should be mutating, but you can mutate the error message object. I could put that whole string of error.message with this new string inside there, all inside the instantiation of the error, but you can mutate it later on and add all sorts of data to it if that's going to help you debug your error, because that is what's going to get sent to the server through track.js or Sentry or whatever it may be. Does that make sense? Now well, actually, before we move on to the next, I want to mention, when you're coding, when you come across a problem that's particularly difficult to debug, you should do this. Think about where you create your error and make sure that where you're creating your error can help you debug it later on, especially if it's a rampant problem that you're seeing throughout your application. So now I'm going to do a little bit more complicated of an example here. So we're going to have to kind of slowly walk through this. Let's walk through the left side first. So this is a promise chain. And I want to propose the question as we go through this: where should you add your catch statement in a promise chain? So on the left side, we have a run function. We're calling run. Inside run, we're calling make promise. Inside make promise, we are calling make error. Make error creates a promise that just produces an error. That's all it does. Promise.reject. Our Trico-Bezoar error is back. Inside make promise, notice we do not have a .catch statement here. Instead, our .catch statement is up here because we have two .thens. So I'm going to propose the question to you guys: should there be a .then statement or the .catch statement on both of these .thens, or just one of these .thens, or either or of these .thens? Is there a difference? Who thinks that you should do the one on the left? Who thinks you should do the one on the right? Okay. Well, let's think about it for a second. Let's specifically look at the one on the right. So when this error is created inside make error, that is going to get caught. In either scenario, it's going to get caught and logged. Either way, it's going to happen, it's going to work. Okay? But the problem that's going to happen with the one at least on the right is what happens when there is an error inside our dispatch code. If there's any error inside of our dispatch code, it's going to be completely swallowed, and you're never going to know about it. And it's going to die. And not just your dispatch function, but any synchronous code that your dispatch function calls, any error that exists entirely in that entire stack, you're never going to know about it, which is not good. Question? Yes. Still, wherever the error is created, that's where your stack trace is going to be. So the comment is, how do I rephrase this? Essentially that usually, the comment was, usually when you use a catch statement, it's something you're trying to expect and handle in a special way. But on the left side, we're catching any error that's going to happen. Is that essentially what you're saying? And that's what I want to do. Like, sure, I might be extra smart and be able to come up with all the scenarios that my code might break in, and there might be some predetermined error cases that I want to handle inside a catch statement. But I need to at least have a catch statement somewhere, and that's the point with promises. If you don't put a catch statement anywhere, then like it's not even just that you're not expecting errors and you're not handling these expected errors. It's like you can have an error that you had no idea could ever even have taken place. Like say your backend is returning a bad JSON object. Well, you're never going to know that on the front end if you don't have a catch statement. Yes. Okay, so he's saying that the expected error should be caught as close as possible to the most original point of the error. And then at the same time, you want to handle all those unexpected scenarios as well. Yes? Okay, agreed. Agreed. I'm more concerned at the moment about the unexpected scenario. Because if it is expected, if specifically you do expect an error to show up inside make promise, then sure, you can have a catch statement right there as well. And that's where you'd use a catch in both promise statements. When you expect it on the one, but you always need to at least have it in the root, if that makes sense. So, and that's what I guess I really want to emphasize here to everyone. Whenever you're using promises, you need to understand your promise chain. You need to understand and make sure wherever you have a .then statement, somebody has to eventually be catching that. If you don't catch it directly right here, like on the left side, make sure at least that you're returning that and somebody else is catching it, or somewhere, somehow, somebody's catching it. Because if you don't, you're going to be getting errors, and you will never know about it, but your users sure will. So what about async functions with error handling? So async functions are kind of like a fancy way of doing asynchronous code as if it was synchronous. So with this example, I have this sleep function. There's nothing special about this sleep function other than it just returns a promise that's going to resolve after a set amount of time. But when we go inside the run function, that is special. It has the async keyword. It also has these keyword awaits throughout it. The way this will work is I can console log 1. I can say await sleep 1 second. And then I can keep doing that. So it's going to console log 1, wait a second, console log 2, wait a second, console log 3. And it's going to execute that code as if it was synchronous, which is kind of nice. It's pretty nice. With error handling, actually even without error handling, I try to understand async functions by translating them in my head to what they look like with promises. So this is almost like a translation of that to promises where it's nothing fancy. But really what I want to dwell upon here is error handling with async functions. So in this case, if I'm awaiting make promise, and make promise is throwing our tricobezoar error, is that console log statement ever going to print? No. No, it won't. Because our promise never really resolves. And because it never resolves, our await statement is never going to progress. And this is particularly bad if you use root async functions for your whole application. So like if your main startup function is run or like run app, and that's an async function, and you're like doing asynchronous stuff in there, and if there's an error, it's not going to proceed if you're not expecting it. And how do you expect it with async functions? You can do a try catch. And so essentially that makes it you're handling asynchronous errors as if they were synchronous errors inside your JavaScript code. But really, again, this is just console.erroring an error. This isn't really bubbling out and going to window.onError. So can I do this? Inside my catch statement, can I just throw the error? Who thinks yes? Who thinks no? Everybody else is just like, I don't know. Okay, well, no, you can't do that because async functions themselves produce promises. And you have to have a catch statement with a promise. So if you do that, you're never going to know about the error. The same thing. It hits us again. The tricobezoar is back. So that's not good. So again, if you're ever using async functions or you're ever using promises, make sure you're catching your errors. So let's go back to these. I mentioned these at the very start. We talked about this cannot read property value of undefined. I didn't really talk about failed to fetch. Let's talk about failed to fetch. Well, as we dove a little bit more into how does failed to fetch happen, we saw these particular errors inside our application with failed to fetch, and there were a lot of these. So if the server is not available, failed to fetch happens when you never even get inside this .then statement. You're never looking at a response.ok or if response.status is a 400 or something like that. You're never in there. you're in a .catch. That happens when the server is unavailable. And lo and behold, we discovered our rolling deploys were broken. When we thought we were deploying code on the back end to a new server, we thought it was getting pulled out of the load balancer rotation. It wasn't. And so all of a sudden, our front end code is making a request to the back end, and the back end doesn't exist. We get a failed to fetch. And so if you're seeing this inside your application, that's one thing I would look at. Another thing is CORS issues. CORS issues, so when the server doesn't return the right headers, if the browser thinks you don't have access to this API, it's never even going to let you get into this .then statement. It's never going to give you a 403 or a 401 or anything like that. Instead, it's just going to catch and say failed to fetch and give you no information whatsoever. It's not going to say you had a CORS problem. It's not going to say the server didn't exist. It's just going to tell you failed to fetch. So specifically, we had one particular backend service that only when they returned 401s was not setting CORS headers. So when they did 200 responses, when they did 403 responses, they were always setting CORS headers. Only when they did 401s, they did not set CORS headers. And when they did that, on the front end, we get a failed to fetch. And this is really hard to debug. And so again, if you're seeing these failed to fetch, I'd recommend you look at CORS issues and or potentially rolling deploy issues. Are your deployments, your backend working properly? So what about our object-to-object errors? So I talked about this. So this is where I admit some pain or I was just really dumb. So we had some common AJAX handling code that whenever the response was not okay, we're like, well, we want everything on the response object. We want all of that logged to the server. Let's just throw the whole thing. Isn't that a great idea? No, it's not a great idea because you're throwing an object, and that's going to get two-stringed as object-to-object, and that's what's going to show up on your server. And now you got a couple thousand of those that are all the same thing, and you have no idea where they're coming from, and life really sucks. So, in closing, I want to go over a few points. First of all, only throw and promise.reject error objects. Make sure you are doing new error on your error object. Always do that. There's no reason, unless there's some crazy thing somebody's doing in some framework where they're throwing something that is not an error object for logical flow, which would be really crazy, weird stuff to do. But in any normal sense of you always want to throw error objects. Also, make sure all of your promise chains have a proper catch. Whenever you're using a promise, no matter what, whenever you see new promise or promise.resolve or anything like that, make sure that it is being caught properly. That doesn't mean every .then needs a .catch, but you need to make sure if you're chaining it or it's getting returned or whoever's consuming it, that somebody is catching it. Because if nobody's catching it, that's going to get swallowed and you're never going to know about it. And the last thing I really want to emphasize is coding defensively with debugging in mind. So think about your errors. Think about how you're writing this code in a way that's going to be easy for somebody to come back to it later and find, resolve issues. Specifically, I find that spots that you should really think defensively about are the edge cases of your application where your app is communicating with somebody else. So whenever you're making AJAX requests, whenever you're posting messages maybe to another system, or I don't know, whatever you may be doing where you're I have my internal state and now I'm communicating with another system's state. Whenever you're doing that, pay particular attention to coding defensively, especially with a language like JavaScript where it is loosely typed. Also because you do not control what another system is returning to you. Though the backend may say they're going to return a particular JSON object, they may not. And so make sure you code defensively, and how you generate your errors. You can call new error whenever you want, wherever in the stack you want, if it's going to make your life easier when you're trying to debug it later on. And I want to emphasize that. Last of all, I just want to say, if your app throws and there's no service there to track it, does it really make an error? Or maybe more importantly, if your promise throws and there is no catch statement, does it really make an error? It doesn't, but it does, because your users are suffering because of it. And so, thank you. Any questions?
Do I have time? Oh. We do have time, and you ended at the right amount of time. Questions?
Yes. Question here.
I'll answer those.
Yep. Well, yes, if you do catch it, but once you catch it, the thing is, there's no differentiation between a CORS error or like the server isn't there error. Once you're inside that catch statement, all it tells you is failed to fetch. Node fetch might be doing something nice for you. I'm talking about Chrome. Like, we spent months on this failed to fetch thing until we really found out it was that 401 issue. And it did not tell us that there was any CORS related problem whatsoever, even though we had an error object. Yes, you actually do in the console. And that's something to realize with a lot of these errors, is a lot of times when you trigger these errors, when you don't have a promise catch statement, it will show up in the console currently inside Chrome saying, warning, uncaught promise exception. And when you see that, there should be a huge flag in your mind. Oh my goodness, somewhere in my code, I'm not catching a promise error. I need to go find that. I need to go fix that. Yes, you'll also see CORS errors potentially inside your console as well. But you're not going to see that in window.on error. That's my point. Tim. I don't know. So the question is, are they going to change the promise spec to make these errors globally show up? That's a great question. I don't know if there's like a JavaScripty reasons why they did that with the specification itself. Apparently there is a reason right here. What's the reason? Ooh, that's new. So apparently there's a new global error handler that is not window.on error, which is a like on unhandled promise exception or something like that. That is in Node. That's available in Node. It is in Chrome? Ooh. Oh man. Yeah, that's amazing. That's awesome. Thank you. Any other questions? Joel. So the comment is the reason why it doesn't show up in window.on error is because the browser doesn't know if you're going to catch it or when you're going to catch it in the future. And so it assumes that you are going to do it at some point in the future and with the asynchronous nature of promises. Until it's garbage collected, yeah, which kind of sucks. Another question? Yes? Potentially, yes. The question is, would you use the same approach with chains of observables? You know, it depends upon, so with observables, I think it's different in the sense that if you're going to throw inside observable code, it's not this native behavior with promises where it's actually swallowing it. So you probably can still get your error out, but for actually doing legit observable error handling, I'd assume you'd want to use the operators available to you in Rx rather than always trying to default to this other thing. Yeah. Another question? Cool. We're good.